In this video, I want to go through one-way ANOVAs. So what they are, when you would use them, and how to perform them in R. And as you go through the ANOVA topic, you'll realise that it's actually quite similar to a t-test, but the code for how to do it in R is quite different. So the ANOVA model compares the means among groups defined by the categorical variable. So similar to a t-test, you're comparing means and the difference between these means based on some kind of categorical variable. In the case of the ANOVA, you're comparing this for more than two treatments. And remember that you need to check the assumptions of the ANOVA before you can perform it, and to check on those, go back to that general ANOVA video and I've already covered. And what you're doing essentially by plotting a linear model, so this is the average of all of the different categorical variables, and what you're doing is testing the difference from this average to the different treatments in your categorical variables. So you're saying from the average how far this is above and this is below. And that essentially is what the linear model is doing. So you would use a one-way ANOVA when you want to test the difference in crop yield with three different fertilizers. So you have categorical variable here with three different treatments, and you're looking at how this affects the crop yield. So let's just have a quick look at how you would do this in R. I'm already in my ANOVA working directory. To do a one-way ANOVA, the first thing you need to do is read in your data set. So I'm looking at the difference of three different fertilizers on crop yield. So I'm reading in the data, and let's have a look at what those headers are. So we've got crop yield and fertilizer. So let's have a look. So we've got crop yield, and then we've got different fertilizers. So we've got nitrogen, potassium, and phosphorus. So we're looking at those three fertilizers and the effect in terms of crop yield on one particular crop. So what we first need to do to check for those assumptions is have a look and see whether that data is normally distributed. So I'm going to check potassium first. So you should be familiar by now with the subset function. So I'm going to check it for potassium, check it for nitrogen, and check it for phosphorus. And what I'm going to do is have a look using the histogram. So I'm going to have a look at potassium. See, this tends to follow a normal distribution. For nitrogen as well, you tend to have a normal distribution. And for phosphorus as well, you could eyeball this and say that this is approximately normally distributed. We're going to say that's okay in this case. First of all, you need to create an ANOVA model. So I'm going to call it crop one way because I'm doing a one-way ANOVA underscore model. And to produce the model, you're going to use LM, so linear model. And similar to what you've seen with a two-sample t-test, you're going to do crop yield. Anything to the left of the tilde is your response variable. In this case, we're looking at the response of crop yield. And then to the right is your predictor variable, so in this case, fertilizer. So we're having a look at the effect of fertilizer on our crop yield. And the data we're using is this crop one way. So let's first create that. So we've created a model, and you can just look at what that model does, and it will give you what the coefficients are. So you don't really need this. So you've got your intercept and you've got the different fertilizers. However, to actually have a look and generate your p-values, you need to use the ANOVA function, so ANOVA, and then in brackets, just that model that you've created up here, so that linear model you've already created. So let's have a look and see what that does. So that's given us our analysis of variance table. The response was crop yield, so we wanted to see what the effect of those three different fertilizers was on crop yield. And you can see that fertilizers, you've got your degrees of freedom, so that's 2 and then 107. So make sure to check the workshop for how to report these correctly. And then here you've got an F value, so for the ANOVA you've got an F statistic. And again you have a probability score, so again this is 2.2 times 10 to the minus 16. So that has 3 dots and it's saying that this is 0. We would never report a p-value as 0. So instead we would report this as p is less than 0.001. So that's given us, looking at across all three treatments, we can say that there is a significant difference of fertilizer on crop yield. But what we really want to know is, where do those differences lie? Are there differences between those 3 different fertilizers? And to do that, we need to do a post hoc test or multiple comparison. And then the one that we use is the Tukey HSD test, but there are a number of different ones that you can do. However, we're just going to focus on the Tukey test. So to do that, you need your model in a slightly different format. So we're going to produce a crop one way underscore AOV. And to do this, we just use this AOV function and we feed it a model that we've already created in R. So you can see that that appears over here. This is because this is the format that that Tukey test requires it in. We're then going to use this Tukey HSD function, and we're going to use that crop one way AOV model that we've just created, and we're going to order it. So ordered equals true. So if we run this, you can see that it's ordered and compared each one individually. So we can have a look here, and these are adjusted p-values using the Tukey HSD. And what this means is comparing potassium versus nitrogen. So here the p-value is 0.1, so above that critical level of 0.05, so there's no significant difference here. However, if you compare phosphorus to nitrogen and phosphorus to potassium, you can see that it's giving us a p-value of 0. So we would report that as p is less than 0.001. And so there is a significant difference between phosphorus and nitrogen and phosphorus and potassium. And if we're going to run a box plot here, you can see that actually that's true. So you can see nitrogen, phosphorus and potassium, and you can see that phosphorus is different to both of them and tends to yield a higher crop yield than either the nitrogen or potassium. So that was just a quick run through of how to perform a one-way ANOVA and a post hoc comparison test to have a look at where those differences lie.